Alright, in this tutorial we're going to show you how to go from a tail on the left hand side that's just this kind of white tail. I'm sorry, the flicker is due to the screen capturing, not anything wrong with the program. And then we'll get to a point where we can get this kind of rainbow tail or this like pink random tail over on the right hand side. So let's get right into it. Alright, we're going to do that by creating a new class in our graphics package called like particle tail. Oops, particle tail. That's going to extend tail or a particle. So sorry, extends particle. And we're going to need to provide a constructor that takes in at least as much information as the particle class. So particle tail. So that's a double X position, a double Y starting position, a color object, C, and I think I need to then send the superclass the X, Y, and C values so that it can handle that for us. We need to import the color object. And then we're going to make a slight change to the, this frankly could just be another type of, another constructor in the particle class, but we're just going to do a different one to kind of, emphasize aspects of inheritance. So in the constructor, we want this particle to be a little bit different. So we want it to be kind of a randomized, or I want it to be a randomized pink color. So we're going to create a random integer green equals int, cast it to an int, math.random times the range. So again, this is one above the range. So the range of numbers is now 0 to 255. We're going to set this.c equal to a new color of 255 green and then 255, which is the way you get a range of pink values. Also, I should say that in the particle class, you will have to change these values to protected, or fields, excuse me, rather than private, so that subclasses, the particle tail subclass, can access them directly. So if you're getting an error, that might be the cause of it. We also want to adjust the dx and dy, so adjust the velocity of the particle so that it kind of streams away from the ball. So we need to take in a couple extra parameters. We need to know the direction the ball is moving in the x direction and in the y direction. And we're going to use, sorry, I can extend this. We're going to use these velocities to calculate a new velocity in the opposite direction for this particle so that it looks like it's kind of poofing out the back, like it's exhaust or something. So to do that, all we have to do is say the dx that represents the particle dx now. Let's just get clear on which values these are. So dx is the particle dx right now. We are making changes to these fields in the particle class, in the particle tail class, and we are going to use the ball dx and ball dy to make those changes. We're just going to subtract the value of ball dx from the randomly generated particle dx, and then the dy is going to equal, we're going to subtract the dy from the particles dy. So we're going to take away the balls dy from the randomly generated dx and dy of the particle. And then we need to incorporate this into the ball class. So if you already have a ball object that's using tail, we can just kind of make a slight change to it. So we are going to, instead of I already added one, so we're going to add I'm calling it a rainbow tail. You can call it whatever you want. So we need to add a private list of particle objects called, I'm calling it RB tail, rainbow tail. And then instead of drawing this tail object, this array list or list that represents the tail, we are going to incorporate rbTail equals new array list of particle objects, not shape objects. And under update tail, all we need to do is to change this from the particle, or from the original tail to rbTail, or whatever you're calling the new particle tail. And we just want to kind of monitor its size, just like we do with the other thing. And then we want to cycle over it and iterate over it and add a new, in this case not an ellipse2d.double, we are going to add a new particle tail object. And we have to send it the, let's see, in the ball class, the ball already knows its excuse me, x, y, and dx and dy. So we're just going to send it those values and the ball's color. So we're going to send it x, y, color, dx, and dy. And now is color my color? I might have used that name, my color. Excuse me. And we have to import particle tail into the ball class so that it can see it because it's in a different package. And now if we have to add one thing here, because the particle tails, unlike the other tail object, the particles need to update themselves and actually do a little bit of travel. So we're going to use an enhanced for loop, and we're going to say for particle p rbTail, want to iterate over that, and each time we want to p dot update, so that it can change its position based on its velocity. And then finally, under the draw method, instead of saying g2.fillS, so we need to change this enhanced for loop now to reflect what we want it to draw. So particle, let's say p, and we want to go over rbTail. Then we want to say p.draw, and we send it g2. Now if I've done all this correctly, it should actually work. So let's open up the correct game window and run our program and see if in fact I have changed it from a white tail to like a shimmery pink tail. And I have. Alright, great. And that is all you need to do to create kind of a randomized sort of exhaust trail rather than just the kind of streaky ball tail. And that is plenty.